Section 1.5 focuses on segments and angle bisectors. So we're going to start off talking a little bit about a segment. When we're talking about a segment, we've talked about things with segments before, that they have two endpoints. Today we're going to be focusing on what we call a midpoint. And a midpoint is just a point that divides or it bisects a segment into two congruent segments. So looking at this segment that we have here, M would be considered the midpoint of that segment, and it divides this whole segment into two congruent parts. So we could put our little congruence marks on there to show that those two measures are exactly the same because that segment is bisected by that point M. To bisect is to divide into two congruent parts. So we know that when we say that something is bisecting, usually the midpoint, or not usually, the midpoint does lie on that bisector that is dividing that segment into two congruent segments. So when we talk about a segment bisector, you could talk about either a segment, a ray, or a line, or even a plane that intersects a segment at its midpoint. So if it's intersecting at the midpoint, we know again that it's forming two congruent segments. Notice this thing could be anything that's bisecting the segment. It could be a line, but it could be a ray. It could be a whole plane that intersects that segment, but we know that it's forming two congruent segments with our original segment.
Okay, so if I asked you to find the midpoint of just this segment, notice it's just a horizontal segment, how could we go about doing this? Well, I'm just going to add something in here. Let's say this is point A and this is point B. If I asked you to find the exact location of the midpoint of this segment, how could we go about doing this?
Well, we know, if we talked about that ruler postulate before, that we could find the whole distance, the length of that segment.
Okay, so I could find how long this segment is, and to do so, we just do
the absolute value of 12 minus 2.
Okay, and when you do that, you get 10. Now, is that the actual location of the midpoint?
No, that's the length of the whole segment.
Okay.
So we know that the midpoint should only be halfway.
Okay.
So it's only 5 units to get to the midpoint.
So if I kind of cut this in half, I get 5. Now, is that where the midpoint is located?
No, because it's not starting at 0 and ending at 10. But we know the whole segment is 10 units long, so at 5 units long, that should be
So if I add up to 5 to this, my midpoint's going to be at 7, and the distance from here to here is 5. The distance from here to here is also 5. Making these congruent segments. Okay. Is there a way to find the actual location of the midpoint, so this number 7, without finding the distance of the segment?
Well, I'm noticing that if I took the 2 and the 12...
Okay. What do you want me to do with those?
Well, if I add them, that gives me 14, and 7 is half of the 14.
So if I add those, I get 14, and then I cut it in half because of this idea of midpoint being exactly kind of in the middle of the segment.
Yeah.
You get 7, which is the midpoint. That's a little bit less work involved. It gives you the actual location.
Well, then we don't have to remember about adding that original segment to it, too.
So when you add, just kind of thinking, if you add two numbers together, any two numbers together, and you divide by 2.
It's like we're averaging them.
So this is like finding the average of those coordinates, right? Because those are the coordinates of A and B. This leads into a new formula.
All right, and the midpoint formula says that if you have 2 points, and we've just called them point A, whose coordinates would be x, 1, y, 1, and point B, whose coordinates would be x2, y2, then when we're talking about, and this is in a coordinate plane, so they don't have to be a straight horizontal line, then the midpoint of that segment will have the coordinates that are averaging the x values and averaging the y values.
So this part right here, the first part of, again, notice there are parentheses around it. This is finding the actual coordinate of the midpoint, the coordinates. So this is the x coordinate. This is the average of your x's. So kind of think of it that way, like Ms. Hochgravy said. So average of your x's. And then this part is the
average of the y's.
Average of the y's. So it's not like you have to memorize another formula. It's more just if you can remember average when you're finding midpoint, if you can just think average. And notice you're just adding the x's, dividing by 2. Adding the y's, dividing by 2.
And of
Seems
course,
pretty
we only have
simple.
to divide by 2 because there's just the 2 points.
Yeah, perfect.
Now, angle bisectors, a ray that's dividing an angle into 2 adjacent angles that are congruent is what we would call an angle bisector. So again, it's bisecting an angle. It's forming 2 congruent angles.
So in this picture, if I told you, if I said ray CD was the angle bisector, I'm just going to kind of write this off this side, of angle ACB, what would that mean then?
That would mean that angle ACD is congruent.
You said D, not B.
I did. It's all right. Angle ACD is congruent to angle DCB. So it's forming 2 congruent angles. Notice that they are adjacent angles, because anytime that I'm talking about bisecting an angle, I will have 2 adjacent angles that are going to be congruent. They don't have any overlapping parts, and they do share that one common ray.
And to share that in the picture to kind of show that they're congruent, those, you can show your little tick marks. You could do it that way, or you could just do little loops. I like to do the little tick marks.
I do too.
Just something I'm used to.